My name is Dr. Joseph Cione. I work at NOAA's Atlantic Oceanographic and Meteorological Laboratory in Miami. My title is Lead Meteorologist for Emerging Technologies, and I've been leading a diverse team that includes NOAA, includes the private sector, includes other agencies, and we are really proud to be testing this new technology to improve our ability to forecast these dangerous storms that impact the United States and our partners throughout really the Caribbean and other places. So the Emerging Technologies group that I lead is really about finding what's next, finding areas to observe and sample that are hard to get to, either because they're dangerous or the equipment that we send down there has a hard time surviving. But the one commonality is we need to get into these regions to help protect property and save lives and to improve future forecasts, particularly for hurricane intensity change and track as well. In 2014, we had our first flight using the Coyote, and we continued to fly for a couple more years using that platform. We learned a lot, but that was a military platform, sort of a holdover platform. And we decided to get to the next generation where we'd say, let's get a weather drone specifically met our needs, and we used the SBIR program initially to do that. And now we have two platforms that have come out of the SBIR system, the Altius 600, which we flew famously in 2022 into Ian, and we also have Black Swift's S0 platform that really does the same sort of thing as the Altius. They both measure pressure, temperature, winds, humidity, but they're deployed from the P3 system, which allows us to get sort of a taxi into the storm so we don't have to spend a lot of time getting into the storm. And we use the P3 also to help us send the data back and get that data into the hands of the forecasters in real time. That's critical to this. That's sort of the last mile of what we're doing, and making sure that data gets there so that the forecasters and the emergency managers can make life-changing decisions of evacuation, not evacuation, and give us the latest on what the storm is really doing prior to landfall. These drones that I'm talking about have a duration of 1 to at most 4 hours. So that's never going to be enough to get to the storm. So the P3's primary critical role here is to get us to the storm and then deploy us in that storm. And those are not trivial, particularly deploying in the storm. Most of our failures, as we've gotten to done testing over years, believe it or not, are not that the platform couldn't survive in the storm. That's happened, but much more of a bigger hurdle is you're launching a plane from a plane. That's not simple. And you're ejecting this secondary small plane, which ranges in size between 3 and 27 pounds, tiny. And you're ejecting it at 220 knots into the airstream. That's a lot of G-forces. It's difficult. So the P3 is critical to get it there and allow us to operate in that environment. The second thing I'd say the P3 is critical in is communicating. So we're not using satellite communications at this point. Maybe in the future we'll explore that. But right now the data goes from the drone, it has to go somewhere, and that somewhere is the P3. So the P3 is offering a valuable resource in that it's a data relay for us. So the P3 is getting us there and making sure the data gets from the UAS back to the P3, and then from the P3 back to land so we can get it to our operational center. So the P3 is also critical in another way because we can use it to validate this data. The P3 has remote sensing systems. We can get winds from tail Doppler radar, we can get dropsonde observations, and we can also get step frequency microwave radiometer, which gives us surface winds, all of which can be used to help validate these new technologies. So the P3 is critical in many regards. I feel blessed that we have such a great NOAA team. I just think that this project really merges a lot of things that NOAA does well and trying to make that as efficient as possible at all times. My name is Dr. Joseph Cione. I work for NOAA's Atlantic Oceanographic and Meteorological Laboratory. I am the lead meteorologist for emerging technologies.